let's be real. You don't just learn organic chemistry. Today, we're going to hack it. We're building the ultimate blueprint to master one of the most foundational chapters in your NCERT textbook for NEAT, basic principles and techniques. Ready? Let's dive in.
So this is the big question, right? You open up this chapter and it just feels like this endless sea of molecules. I mean, the NCERT book itself says there are millions of these compounds. Your first instinct is probably to start memorizing, but let me tell you that is a trap. It's a losing game, and it's not how you're going to crack this subject.
So what's the secret? What's the hack? It's right here. You don't memorize millions of compounds. You learn the code that runs the whole show. This chapter isn't a phone book you have to memorize. It's a rule book. If you understand the rules, you can predict the behavior of pretty much any compound they can throw at you in the exam. So let's start decoding. And that code, you guessed it, it all starts with one element, carbon. Think of carbon as the main character in our story. The entire universe of organic chemistry is built on its amazing, unique ability to form super stable chains with itself. It's a property called catenation. To get the story, you gotta understand the hero. So how on earth does carbon form so many different kinds of bonds? Well, the secret is this really cool concept called hybridization. Just imagine carbon taking its existing atomic orbitals, throwing them into a blender, and whipping up these brand new specialized hybrid orbitals that are absolutely perfect for bonding. This is the key to its incredible versatility. It's how we get everything from methane to ethene. Okay, zoom in on this table, because this is where the magic happens. Look at that top row, S character. As that number goes up, from sp3 to sp, the bonds actually get shorter and stronger. Why? Because the s orbital is snug and close to the nucleus. This also cranks up carbon's electronegativity, making it better at pulling in electrons. This one relationship, straight from page 257 of your NCERT, is the secret to solving tons of neat questions on bond length, strength, and even acidity. This is pure gold. Okay, let's move on. Now that we understand our builder, carbon, we need to learn the language chemists use to talk about all the cool stuff it builds. This really means two things: understanding how molecules are drawn, and super importantly, how they're named using the IUPAC system. So, NCERT shows you 3 ways to draw a molecule. The complete and condensed formulas? Yeah, they're useful. But for NEAT, let's be real, you need to be a ninja with that third one, the bond line formula. Why? Because it's fast. It cuts out all the noise and lets you see the carbon skeleton instantly. Mastering this isn't about looking cool, it's about solving problems way, way faster. I know, the full IUPAC rulebook can look super intimidating. But trust me, for the most part, it all boils down to this simple 3-step logic. Step 1, find the longest carbon chain. That's your parent name. Step 2, number that chain, but start from the end that gives any branches the lowest possible address. And finally, step 3, name your branches and list them in alphabetical order. If you can nail this core process, you've basically got the foundation for all IUPAC naming down. All right, we know what carbon is, and we know the language to describe its molecules. Now for the really exciting part, understanding their behavior. See, organic reactions are all about the breaking and making of bonds. So to figure out how a reaction even gets started, we first have to understand how a bond breaks apart. A bond can break in one of 2 ways. Think of it like sharing something. Heterolytic fission is an unequal split. One atom gets greedy and takes both electrons, creating charged ions like carbocations. On the other hand, homolytic fission is a perfectly fair split. Each atom gets 1 electron, creating neutral but really reactive things called free radicals. And which path a bond takes, unequal or equal, pretty much determines the entire reaction that's about to happen. You know, even before a bond fully breaks, electrons are always being pushed and pulled around. The inductive effect is kind of like a short-range tug-of-war on the sigma electrons. But the resonance effect? Oh, that's the real game changer. It's this complete delocalization of pi electrons across a whole system. It's less like a tug-of-war and more like a shared cloud of electrons just floating around. And that delocalization, that sharing, is a massive, massive source of stability in molecules. Now for the part you've been waiting for. Let's connect everything we've talked about directly to the exam. This is where we prove that the code for this chapter isn't just about understanding the concepts, but it's about recognizing the exact lines from your NCERT book that turn into questions. Here's a classic question. You will absolutely see something like this. It's asking you to rank the stability of different carbocations, those things we just saw from an unequal bond split. So how do you solve this in seconds without guessing? You don't, because the answer is written word for word in your textbook. And boom, there it is, page 271 of your NCERT textbook. It gives you the exact order, and it even tells you why. Those alkyl groups help stabilize that positive charge through the inductive effect, and another cool thing called hyperconjugation. But simply put, the more alkyl groups attached to the positive carbon, the more stable it is. This isn't just a hint, it's the literal answer key hiding in plain sight. This slide right here, this is the whole strategy. This is the map. The NCRT statement is the source code. The neat question is just the program it runs. The exam is really just testing one thing. Did you read and understand this specific line? This entire hacking method is all about finding these high-yield lines and truly getting the concept behind them. Okay, let's pull everything together into your final blueprint. Think of this as your 30-second revision tool. Right before you walk into the exam, this is the stuff you need to have absolutely burned into your brain. These are your triggers. The keywords catenation to resonance, you have to know their definitions cold. The key order, carbocation stability, is tertiary, secondary, primary. That's a guaranteed question right there. The key concept, more S character means stronger, shorter bonds. That explains so much about bond lengths and acidity. And the one must know shape, the perfect tetrahedron of methane. This is the absolute core. Master this, and you're golden. So there you have it. The code is cracked. You see, organic chemistry isn't about some superhuman feat of memorization. It's about understanding the rules of the game. And those rules are laid out for you right there in your NCERT book. You have the blueprint now. So the only question is, which chapter are you going to decode next? Thanks for tuning in.